Welcome to the Ham Radio Nomads study session. Today, we are going to be doing something a little different. We have been going through the study questions for a while, and we are going to try a practice test tonight. So, if you want to join in and answer questions live, click on the StreamYard link up top, and I will add you in to the conversation. Otherwise, keep track of your answers, and I will be asking how well people did at the end. I do not know if I will get through a full test. The amateur extra is 50 questions. So I do not know if I will get through a full test in the hour that I'm going to do it today, but I'm going to try. So let us get started and see. And if I can, I'm doing a little bit different, so let's get started with the practice test. And I will keep an eye on the chat. If anyone does have some questions, meantime. On the Smith chart shown in figure E9.3, what is the name for the large outer circle on which the reactance arcs terminate? And A, prime axis, B, impedance axis, C, reactance axis, D, polar axis. I'm going to guess C, reactance axis. And unlike when we're doing study questions, it does not, you're guessing D. So unfortunately, it doesn't give me the answers right away. So it is, we will see how it goes at the end. And welcome, Ham Radio Dude. Thank you for joining me on my trip through a practice exam and seeing how I actually do. What is the function of a vertical interval signal code sent in part of the SSTV transmission? A, to identify the SSTV mode being used. Oh, no, go. How many do? Not a problem. We're all going through this, and it is, I'm picking C, you're picking D. We'll find out at the end. Hopefully we'll see what the actual answers were at the end. But yeah, we'll find out how things go at the end. So what is the function of the vertical interval signal as part of the SSTV? A, to identify the SSTV mode being used. B, to identify the call sign of the station transmitting. C, to provide vertical synchronization. D, to lock color burst oscillator in color SSTV images. I believe I had this a week or two ago, and the code tells which mode you're in. So I'm picking A. What frequency discriminator stage what is the frequency discriminator stage in an FM receiver? A circuit for detecting FM signals. B, a circuit for filtering too closely adjacent signals. C, an FM generator circuit. D, an automatic band switching circuit. Okay, the circuit for FM generation is in a transmitter, not a receiver, so I'm pretty sure it's not C. I'm going to guess A. I'm probably wrong, but I'm going to guess A anyway. So, yeah. What happens to the magnitude of a pure reactance when it is converted into subsistence? A, it is shifted by 90 degrees. B, the sign is reversed. C, it is unchanged. D, it becomes reciprocal. I believe it becomes reciprocal, but we will find out. Thank you for all those who are watching, and keep track of keep track of how you're doing, and we will see how we do as far as we get in an hour. Which of the following describes problems caused by poor dynamic range in a receiver? A, cross modulation of the desired signal and insufficient audio power to operate the speaker. B, oscillator instability requiring frequent returning and loss of ability to recover the opposite sideband. Spurious signals. Yeah, that's Philip. That's a lot of what I'm coming to. I don't know what these mean, and I'm just guessing. C, spurious signals caused by cross modulation and desensitization from strong adjacent signals. D, oscillator instability and severe audio distortion of all but the strongest received signals. I am going to I'm guessing it's C or D. I'm going to guess C. What is the beta of a bipolar junction transistor? A, the switching speed. B, the change in collector current with respect to the base current. C, the frequency at which the current gain is reduced to 0.707. D, the breakdown voltage of the base to connector junction. I know I had the question about this, but I don't remember the answer. I'm going to guess B. Why should effective radiated power to a satellite that uses linear transponder be limited? A, to prevent the satellite from emitting out-of-band signals. B, to avoid reducing the downlink power to all others. C, to prevent creating errors in the satellite trimetry. D, to avoid interference with terrestrial QSOs? I believe I think I heard this in Josh's satellite interview, that if one user uses a ton of power, it limits what power is left for the other users. So I'm going to go with B. What is the effective radiated power relative to a dipole of a repeater station, which is 200 watts transmitted power output, 4 dB feed loss, 3.2 dB duplexer loss, 0.8 circulatory loss, and 10 dB gain on the antenna. So if we add up the losses, we get to 8, and we have a 10 gain on it. So it should be just above. It should be just above the 200 watts. So that would put it in either A or D. So 8's a trick question. So yeah, you're right. It is a trick question. I'm just not. Oh, I'm gonna go with D. I might be wrong, and it might be A, but we'll see. Oh, so Smoking Ape is just giving me a hard time during my exam. I think that's an added reason why you're supposed to be, when you take your online exams, you're supposed to be in a locker room with no one around, so that you don't have people in the audience like Smoking Ape heckling the test takers. Sounds good, Smoking Ape. Thank you for watching. And yes, I have no problem with the heckling in the audience. Which of the following limits the highest frequency signals that can be accurately displayed on a digital oscilloscope? A, amount of memory. B, the Q of the circuit. C, all these choices are correct. D, the sampling rate of the analog to digital converter. I'm gonna. All of them actually sounds like they could be. That they could affect the frequency range. So I'm going to click C. What is the most common method of reducing key clicks? A, high pass filter on the transmitter output. B, increasing keying waveform rise and fall times. C, low pass filter on the transmitter output. D, reducing keying waveform rise and fall times. I don't know. I'm going to just guess C. Philip, I'm hoping I haven't missed them all, but we will see. I am 1/5 of the way through, and I am a quarter of the way through the hour. So I think this is going to take me a little longer than an hour. So how is positive feedback supplied in a cool Colpitts oscillator. A, through the capacitive divider. B, through the tapped coil. C, through link coupling. D, through the neutralizing capacitor. I'm going to go through the tapped coil, and I'm pretty sure that's wrong. Also, one question for everyone out there. I am using hamstudy.org for my test questions. Is there another website? The thing I would like to do instead when I do practice tests is be able to get the response right away. Is there another website that that can give? I know the apps on the phone can, but is there a website that will give you 50 set random questions, but will also give you the answers right as you take them? If anyone knows that, raise your hand, and I will make you a moderator, and you can paste in the link in the description. Either that, or go click on the description of this video, go to the Discord's Toad's Discord server, and paste it in the study questions channel on Toad's Discord. Yeah, Ape, that's the same with me. I've used their app, which does give answers right away. At least I believe it's their app, and then their website. I haven't had any experience with anyone else, so I'm not exactly sure what other ones can do. I believe ARRL does have a practice test as well that I might take a look at, but I haven't used them, so I don't know how it works. Question 12. What might be indicated by a sudden rise in radio background noise across a large portion of the HF spectrum? A temperature inversion has occurred. B, a solar flare has occurred. C, increased trans-equatorial propagation is likely. D, a solar propagation. And I'm slaughtering that, and I'm getting answers mixed up. D, long path propagation is likely. I'm going to go with B, a solar flare has occurred. What happens as the Q of an antenna increases? A, SWR bandwidth increases. B, gain is reduced. C, SWR bandwidth decreases. D, more common mode current is present in the feed line. I'm going to go with the bandwidth of the SWR. I believe I heard the Q for a loop antenna is very small, and that causes the Q of a loop antenna is high, and that causes the bandwidth to be small. But I could have that backwards. Well, Smoking Ape agrees with me, and he has a lot more experience with the antenna, so it looks like I probably got one right. What is a programmable logic device, a PLD? A programmable collection of logic gates and circuits in a single integrated circuit. B, programmable equipment used for testing digital logic integrated circuits. C, a logic circuit that can be modified during use. D, a type of transistor whose gain can be changed by digital logic circuits. I am going to go with A. Smoking Ape, I look forward to seeing it. Yeah, I also have a bunch of antenna. I have a bunch of antennas I want to make. And it's just sort of getting my mind around of how to make how to do the videoing. I want to videotape, record them and do videos of them, but I'm sort of working my way around how to best use the equipment I have, because I really don't have funds for better video equipment at the time currently. Which of the following is required in the identification transmission from a balloon-borne telemetry station? A, call sign. B, the output power of the balloon's transmitter. C, all of these are correct. D, station 6-character Mannerheim grid locator. And identification is by call sign, so I'm pretty sure it's A. What is the purpose of capacitor C2 in the circuit shown in figure E7? A, to self-resonate the hum frequency. B, it is a brute force filter for the output. C, it is to provide a fixed DC basis for Q1. D, it bypasses rectifier output ripple around D1. And C2 is right here next to D1, so I'm going to say that it is a bypass rectifier output. How may data rate be increased without increasing bandwidth? A, using a more efficient digital code. B, it's impossible. C, increasing analog to digital conversion resolution. D, use forward error correction. Um, ooh, I think this is a trick question, but I'm going to go with B. It's impossible. Even though both A and C sound like they could be probable, but the fact that both A and C sound like they could be probable sort of tends me to believe that they aren't, and it's actually B. That it's impossible. How can the output voltage of a multi-turn receiving loop antenna be increased? A, by oh, Smoking Ape also agrees with me that it's B. So that's promising. How can the output voltage of a multi-turn receiving loop antenna be increased? A, by reducing the permeability of the loop shield. B, by winding adjacent turns in opposite directions. C, by increasing the number of turns or the area. D, by utilizing high impedance wire for the coupling loop. I'm going to go with B, by increasing the number of turns and or the area. Which of the following is acceptable bandwidth for digital radio mod? I don't know how to say, but DRM, base voice or STV digital transmission made on the HF amateur bands. A 3 kilohertz, B 10 kilohertz, C 15 kilohertz, D 20 kilohertz. Well, A 3 kilohertz is the size of SSB, single sideband. So I doubt that that's it. I know both DMR and SSTV is wider than that. I don't think it's 20 kilohertz. I think it's somewhere in the middle. I'm going to go with 15. What is the output voltage of the circuit shown in I'm thinking of the getting ahead of myself. In the figure E7-3, if R1 is 100 ohms and RF is 10,000 ohms and the voltage is 0.23 DC volts applied at the input. So and this one is going to be I'm going to go with D. There is an equation for it. I don't remember it. I do remember this question before, and I'm pretty sure it was an inverse. And there is, there is a 10 difference. There is a magnitude of 10 difference between the two of these. So I believe that, if I remember correctly, I believe that multiplied the voltage by 10, and then I believe it was there is a negative multiplier in there as well. What is the primary purpose of phasing lines when used with an antenna having multiple driven elements? A, it creates a low angle radiation pattern. B, it allows single band antennas to operate on other bands. C, it ensures each driven element operates in concert with others to create desired antenna patterns. D, it prevents reflected power from traveling back down the feed line and causing harmonic radiation from the transmitter. I believe it's going to be C. And just for, this is something that, and this is something that was in one of the questions last week, or actually last couple weeks. But it talks about how two antennas with how the distance apart and the phase shift, how it affects the patterns of the radiation patterns. Which point in figure E5-1 best represents the impedance of a series circuit consisting of a 300 ohm resistor and a 18 microhenry inductor at 3.505 megahertz. A 0.8, which is 50 Y, positive 50 Y and positive 300X. B 0.3, which is positive 400 Y, positive 300X. C 0.1, which is positive 300X and negative 400Y. D 0.7, which is negative 300X and negative 400Y. I am going to go with 0.1. Positive 300X, negative 400. And let's go back down to 100%. Okay. What is half power bandwidth of a resonant circuit that has a resonant frequency of 7.1 megahertz and a Q of 150? And I do not have a clue. Oh, I'm just going to guess D. So, which of the following digital modes is designed for meteor scatter application? A. Whisper. B. MSK 144. C. APRS. D. How? I have no idea. I don't believe Whisper is. Hey, Andy. Thank you for joining me. I am doing a practice test, and we will see how well I do. Instead of doing my typical study questions, we're trying to do a practice, seeing how well I do on a practice test. Just because I don't really know APRS, I know it's not. I don't believe it's Whisper, so it's either B or D. I'm going to guess D. Which of the following can be used to measure the Q of a series tuned circuit? You think it, so Andy you're guessing B, MSK 144? That was my other one. So yeah, that's, I'm not sure. So that could very well be true. Which of the following is the bandwidth measured series tuned circuit? The bandwidth of the circuit's frequency response. B, resonant frequency of the circuit. C, frequency shift. D, inductance to capacitance ratio. And I'm going to guess A. And following that up, Smoking Ape response is also A. So I am starting question 26 at 36 minutes past the hour. So we are just over an hour. Does anyone know, is Ham Radio 2.0 doing a live broadcast at right after this, or is he off for tonight? Just wondering if I need to end right on the hour or if I can go a little long. What is a photovoltaic effect? A. Conversion of voltage to current when exposed to light. B. Conversion of light to electrical energy. C. Tendency of a battery to discharge when exposed to light. D. Conversion of electrical energy to mechanical energy. Photovoltaic cells are the cells of a solar panel. So it would be B. Conversion of light to electrical energy. Okay, yep. So I am I'm going to see if I can speed it up a little bit and try to get in under the hour. What is the most useful characteristics of the Zener diode? A. Constant voltage drop under conditions of varying current. B. Internal capacitance that varies with applied voltage. C. A constant current dropped under conditions of varying voltage. D. A negative resistance region. Oh, I'm going to guess B. What determines the PEP to average power ratio of a single sideband phone signal? A. Amplifier gain. B. The degree of carrier suppression. C. Speech characteristics. D. Frequency of the frequency of the modulating signal. I'm going to go with speech characteristics. Which circuit is bistable? A, an AND gate. B, a bipolar amplifier. C, an OR gate. Or D, a flip-flop. And I'm going with a flip-flop. Amateur stations may not transmit in which of the following segments if they are located in the contiguous 48 states north of line A. A, 440 megahertz to 450 megahertz. B, 420 megahertz to 430 megahertz. C, 53 megahertz to 54 megahertz. D, 222 megahertz to 223 megahertz. I believe this is B. I heard this first in North Country Ham's study videos, which he is an excellent one. Smoking Ape, can you do me a favor and grab the link to North Country Ham's amateur extra study sessions and paste it in the chat? He is another YouTuber that is a great one to watch. Line A is I think like 100 miles, 100 to 200 miles from the Canadian border. And that 420 to 430 is part of the Canadian commercial band. So we cannot transmit above in that frequency range when we could possibly be transmitting into Canada. I also don't understand why that is just a question on the amateur extra test when technicians can use the 70 centimeter band and could be very likely breaking the law using it in too close to the Canadian border. Next question. Sorry for my rant. How can conducted and radiated noise caused by an automobile alternator be suppressed? A, by installing a noise suppression resistor and blocking capacitor in both leads. B, installing a high-pass filter in series with the radiator's power lead and a low-pass filter in parallel with the field lead. C, by connecting the radio's power leads directly to the battery and installing coaxial capacitors in line with the alternator leads. D, by installing filter capacitors in series with the DC power leads and a blocking capacitor in the field lead. I don't know. I'm going to guess D. Probably wrong, but yeah. Another one I'm just guessing at. How does an impedance matching circuit transform a complex impedance to a resistive impedance? A, it introduces negative resistance to cancel the resistive part of the impedance. B, it introduces transconductance to cancel the reactive part of the impedance. C, it cancels the reactive part of the impedance and changes the resistance part to the desired value. D, reactive currents are dissipated in matched resistance. I'm going to guess C. What transmit frequency might generate an image response signal in a receiver tuned to 14.300 megahertz that uses a 455 kilohertz IF frequency? I don't know. I'm gonna guess C, just because I don't have any other idea. What is the minimum passing score on all amateur operator license examinations? So we can use a calculator on this test. So I'm gonna the standard test has 35 questions times by 70. Yep, that's the one. I know you need to get 25 correct for the standard test. So that's what I just typed into my calculator is I just typed out which one of these times 35 gave me 25. So what is inductor saturation? A, the inductor windings are overcoupled. B, inductor voltage rating is exceeding, causing a flashover. C, adjacent inductors become overcoupled. D, the ability of the inductor's core to store magnetic energy has been exceeded. I'm going to go with D. The storage of magnetic energy has been exceeded. What is reactive power? A, power loss because capacitor leakage. B, power consumed in wire resistance in an inductor. C, power consumed in circuit Q. D, wattless non-productive power. I'm going to go with D, wattless non-productive power. Why might a DX station state that they are listening on another frequency? A, to separate calling stations from the DX station. B, because the DX station may be transmitting on a frequency that is prohibited in some responding stations. C, to improve operator efficiency by reducing interference. D, all of these choices are correct. I'm going to go with B. Which of the following has the biggest effect on the velocity factor of a transmission line? A, termination impedance. B, length of the line. C, dielectric materials used in the line. D, conductor resistivity. I'm going to go with dielectric materials. Which of the following HF digital modes uses variable length coding for bandwidth efficiency? A, PSK31, B, MT63, C, RIDI, D, Pactor. I think it's PSK31. It's either that or RIDI. Question 40. Almost there. Which of the following describes how loading and tuning capacitors are to be adjusted when tuning a vacuum tube RF power amplifier that employs a pi network output circuit? A, the loading capacitor is set to the maximum capacitance and the tuning capacitor is adjusted for minimum allowable plate current. B, the loading capacitor is adjusted to the minimum plate current while alternately adjusting the tuning capacitor for maximum allowable plate current. C, the tuning capacitor is set to maximum capacitance and the loading capacitor is adjusted for minimum plate permissible current. D, the tuning capacitor is adjusted for minimum plate current and the loading capacitor is adjusted for maximum permissible plate current. Oh, I don't know. I'm going to guess D. What is the modulation index of a FM phone signal having a maximum frequency deviation of 3000 hertz either side of the carrier frequency when the modulating frequency is 1000 hertz? I think it's a trick question, but I don't know any different. So I'm just going to say, I'm going to just say 1000, C for 1000. Which of the following frequency ranges is most suited for meteor scatter communications? A, 10 megahertz to 14 megahertz. B, 28 megahertz to 148 megahertz. C, 220 megahertz to 450 megahertz. D, 1.8 megahertz to 1.9 megahertz. I'm used to, I thought meteor scatter was using the UHF bands like 70 megahertz. So I'm going to go with C. Andy, is that for 42? You're saying B, it should be 28 megahertz to 148? You could be right. I know it's I know it's not down further into the HF bands, but it could very well be the lower side of VHF. Yep. So the question is it VHF or UHF? I'm guessing UHF and you're saying VHF. So we'll see in a little bit. I have about 5 minutes to answer 7 more questions. So let's see. When evaluating a site with multiple transmitters operating at the same time, the operator and the licensee of which transmitters are responsible for mitigating overexposure situations? A, the most powerful transmitter. B, each transmitter operating with the duty cycle greater than 50%. C, only commercial. D, each transmitter that produces 5% or more of its MPE limit in areas where the total MPE limit is exceeded. It may be D, but I'm going to guess B. In the antenna radiation power shown in figure E9-1, what is the beam width? So the beam width is basically from here to from negative 30 to 30. So, or unless it's, yeah, I'm going to say it's negative 15 to positive 15. So I'm going to say 30 degrees. But it could be up here. Yeah, I don't know. It could be 50 degrees. Or it could be just below and 25 degrees. I don't know. Why are DIP through the whole package ICs not typically used in HF and higher frequency? A, unstable. B, too many pins. C, excessive lead length. D, epoxy coating is conductive above 300 megahertz. I'm going to go with C, excessive lead length. Which of the following is a type of off-center dipole antenna? A multi-band dipole antenna using one-way circular polarization for frequency diversity. B, a folded dipole center fed with 300 ohm transmission line. C, a dipole fed approximately 1/3 the way from one end with a 4-to-1 balun to provide multi-band operation. D, a remote tunable dipole antenna using orthogonal controlled frequency diversion. And I'm going to go, selecting C because it's off center. So it's 1/3 from one end. And both Andy and Smoking Ape are green, so that is good. Which amateur bands typically support long path propagation? A, 160 meters to 10 meters. B, only 60 meters to 40 meters. C, 6 meters to 2 meters. That's most definitely not it. Only 30 meters to 10 meters. Well, it's not C. B and D say only, so I don't like those answers, so I'm going to go with A. Smoking Ape, can you grab the link to Ham Radio 2.0's live stream and paste it in the channel so I can pin it to the top? I have 3 more questions. Gonna try to get them through. Gonna squeeze them in before wrapping up. What aspect of the receiver's analog to digital conversion determines the maximum receive bandwidth of direct digital conversion SDR? A, processor latency. B, sample clock phase noise. C, sample width in bits. D, sample rate. And I'm going to go with B, or sorry, C. At what level below the signal's mean power level is its bandwidth determined according to FCC rules? A, 26 dB. B, 23 dB. C, 6 dB. D, 3 dB. I'm just going to go with 3 dB. Which of the following carrier frequency is illegal for LSB AFSK emissions on the 17-meter band RIDI and data segments? Okay. Thank you for looking, Ape. I guess I can't send people over there. At least not at the moment. Which of the following carrier frequency is illegal for lower sideband? I'm going to go with C, the bottom edge, because the lower sideband would go below that. So that is it. And here is the point of testing. It is time to grade the exam. What? It can't connect to the server to grade the exam? Yeah. So I guess I don't get to see what my answer, what the, what grade I get. Well, I'll leave it up here. Hopefully it's just an issue. Hopefully I can figure something out. If I find something, I will post it in the Discord to let people know how I did. But yeah, as of right now, it's giving me can't connect to server error. So I don't know. Um, so yeah, I would be looking for a new place to test. Hopefully that won't give me an error when I try to grade. So thank you for everyone that participated and watched today, and we will see you all next week. I will probably do another um, test next week and see if I can actually get a score on what I want on what I do, how I do. Um, so yeah, I guess I don't have a score right now. If I get a score, I'll let you know. But thank you for everyone who came through and is watching, and subscribe if you haven't. Hit the like button if you haven't already. And 73 um, until we talk again. And the next thing I have scheduled is the Thursday practice session, FT8 off practice session. So if we don't talk again on the Monday night ham radio videos tomorrow or one of the other things, hopefully we will talk on Thursday. 73, and have a good evening.